So are we normal? Well, we already established in our class we don't like being normal. We love to be above normal, but how do we know if we're above it if we don't know what is normal? So this particular video lecture is about assessing normality when we have data. So we're not going into Psych 101. We're still into the statistics, which is used in psychology, but that's another story. So turn to page 14 of your notes. So our question is, if we have raw data, can we determine if something is normal? Because the bottom line is left skewed, right skewed. We know our whole premise or our whole reasoning is to eventually get to a bell curve. And if it's a bell curve, it's approximately normal, in which the mean is equal to the median. But how do I tell if they don't tell me that it's approximately normal? How do I make that determination? There's 3 ways. Method number 1, we are going to be using a normal probability plot. That's the first thing I'm going to show you. And when that normal probability plot appears normal, or I should say appears linear, then we know it's approximately normal. I'll show you exactly where the normal probability plot is in your calculator. So here, as I go to second stat plot, after I've turned it on, second stat plot, and I'm just going to go on and write down here is the normal probability plot. And you can see what's going on here. If once we plug in numbers, if that plot is linear, then yes, the data that's been put in there is approximately normal. But let me give you the 2 other things that personally I would use unless I had no other choice, which are, I would revert to old school. I would go with the a box plot, looking at the symmetry, but as I look at the box plot, I'm going to have to compare my mean to my median. And the other thing that I would look at possibly is a histogram. For the histogram, remember, you know what a histogram looks like if it's symmetric, but I also would look at the mean compared to the median. So that's 1, 2, 3 ways that we could determine if our data is normally distributed. Now, turn to page 13 of your notes, because honestly, I screwed up in the order of this when I set this up, but it is what it is. Okay, so here we're talking about the density of the Earth that was determined by Henry Cavendish. And here are the measurements. He did 29 measurements. So what we need to do is take this and put this in our graphing calculator. We know we go to, we go to Stat, Edit, and you notice I already have it in my L1, so go ahead and take a minute and put it in the L1. Now, after you've done that, let's see if this data is approximately normal. So I'm going to go to second plot. I'm going to have the plot on. I already took myself to the normal probability plot. Press enter. Let's put it in my L1. Remember, second above the number 1. And then I'm just going to go calibrate it by going zoom stats. And there is our graph. You can trace it to see what the values are right here. And this is when the value is 4.88. I keep tracing. Here's when the value is 5.07. And what the numbers you see right here are it's a formula that we don't have to know for the AP test, so I'm not going to even worry you about it. But it's a formula that was able to give us its relationship on the vertical axis. So once we have that, okay, I also want to look at what our histogram looks like too. This is going to answer one of our questions, but let's look at the histogram. So I'm just going to go zoom. I'm going to go second stats. Let's go with our plot. I'm going with our first plot. I'm going to go to the histogram, and I should be okay without calibrating it. Nope, I'm not. So I had to do zoom stat again, and here's our graph. So that answers the question for number one, because number one, it says to enter it in the calculator, make a histogram. So this is exactly what I had, and I cut and pasted this from the book because I was going to be lazy and not put it in, but I took one for the team for the umpteenth time. Okay, then they asked us to sketch it, and then we want to go and talk about the shape. So yeah, we can see it's roughly symmetric. We don't appear to have any outliers. I went to first vars, one variable statistic, to find out my mean and my standard deviation. Which takes me to my next question. My next question is, they want us to calculate to see if it falls within 1-2 standard deviations within the mean. So the first thing I did was use the 68, 95, 99.7 rule, and I did the calculations. So you can see here, all I did was do the math for those standard deviations. And then after I've done that, I wanted to see how many of these values up here fell within the middle 68%, because remember, one standard deviation away from the mean is the middle 68%. Well, it turned out that 22 out of the 29, which is 75%, land within the middle 68%. And then here, this is 2 standard deviations away from the mean. And I noticed as I looked up here that 28 out of 29 fall within 2. Remember, that's the middle 95%. And then this last one here, that was the 3 standard deviations within the mean. Remember, using the 68, 95, 99.7 rule. I found that all of them fall within that. Okay, so with the idea of the 68, 95, 99.7, and I know I'm pointing to numbers, those aren't the values, but this is the idea. These are the values that I came up with. Here is the actual raw data, and we're saying that one standard deviation in the middle 68%, it is reasonable for the middle 75%. This is even more reasonable right here. The 2 standard deviations away being the middle 95%, 96.55, and then 3 standard deviations away, which is the middle 99.7%, which is, on this one, is all 100. So therefore, the question is, how do these results compare to the 68, 95, 99.7? And my answer to that, it is extremely reasonable. Now, if your thoughts are, what is the point in doing that? The point in doing this is we want to see, this is just another way of coming up with, if this histogram and the idea of what symmetry involves, which is the 68, 95, 99.7 rule, if these values clearly work with that rule, because if it does, that does mean that the graph is approximately symmetric. Now, problem number 2, we did that in the histogram, not the histogram, I'm sorry, the normal probability plot, and here is the graph. And then the final question was, here, did I ever interpret? No, I didn't. Use the calculator to construct the probability plot. Okay, interpret the plot. We're saying that this information, okay, I'll put it right here. Okay, so this indicates that the data is approximately normal. And remember, if it's approximately normal, we can use a z-score. If it is not approximately normal, we cannot use the z-score. Now, as we look at this right here, we inspected all 3. Here, we had a drawing that confirmed it was approximately symmetric. Here, we used the 68, 95, 99.7 rule and looked at how many of the values fell within the intervals that we developed. And here we use the normal probability plot. So, a brief summary, all of these methods support that this data is approximately normal. So, that ends the topic of normal probability plot. The beauty of this, though, as I go to the next page, looking at the AP tips. Sorry, I was too tired to pause it. Is that, okay, the normal probability plot is not on the AP exam, but it's very useful for assessing normality. And remember, we can always use the box plot and the histogram to look for approximate symmetry, and therefore, if it's approximately symmetry, we can assume, and it's reasonable because we just did it a couple of seconds ago, that if it looks approximately symmetric, then we can establish that it is approximately normal. Bye-bye, people. Peace out. 2 videos tonight, 7 o'clock. Why am I still here? I don't know. Bye-bye.